Hello everyone. Today we discuss about disk scheduling, which come under the subject CS204 operating systems. Before we going into the disk scheduling, let us see what is a disk and what is the need of disk scheduling. Hope all of you remember this figure of memory hierarchy. In this, on the top the registers comes, which is near to the CPU. After that cache memory comes, again main memory, and then disk memory comes. Here in the cache memory you have studied in the computer architecture, and the main memory we have seen in the memory management function of the operating system. And now let us see what is disk and the scheduling of disk. This is the architecture of the disk. It provides massive amount of storage, and each disk is called platter, which has circular shape, and the two surfaces are covered with magnetic material, and the read-write heads are attached to the disk arm, and the arm assembly consider all the read-write head as a single unit. The surface of a platter is logically divided into circular tracks, and each track is divided into sectors. In order to read or write data to the disk, initially the read-write head linearly move to a particular track. After reaching a particular track, the disk is rotationally moved to reach to a particular sector. The sector is the position where we store actual data. And the disk speed has two parts: the transfer rate and positioning time or random access time. The transfer rate is the rate at which the data flow between the drive and the computer. The positioning time or the random access time, which has two major components. The first is seek time and the second is rotational latency. The seek time is the time for the disk arm to move the head to the cylinder containing the desired sector. That is, initially the head moved to a particular track. That the track of the tracks which with the same number of track numbers form a cylinder. The time taken for the read-write head to reach to the particular track or a cylinder is called a seek time. After getting to the particular cylinder, what is the next step? Find out the sector. For that, the disk has to move rotationally. That is the rotational latency. It's the additional time for the disk to rotate to the desired sector. Then the next term is disk bandwidth. This is the total number of bytes transferred divided by the total time between the first request of service and the completion of the last transfer. And what we are trying to achieve is to improve the access time and bandwidth by managing the order in which the disk requests are serviced. We can, by reordering the request we can improve the access time and bandwidth. That is what we are trying to achieve in a disk scheduling. And in this case, if a particular request comes and the disk drive and controller are available, the read or the write request can be serviced immediately. And what will we do if the controller is busy? Then any new request for the service will be placed in the queue of pending requests for that drive. For a multi-programming system with many processes, the disk queue may often have several pending requests. This is the case comes when a multi-programming environment. That is, when more than one request comes one after another, we need to form a queue of requests which has to be serviced later. Thus, one request is completed, the operating system chooses which pending request has to be serviced next. How the operating system make this choice or selection? This is discussed in a disk scheduling. There are various disk scheduling algorithms are there. These are the algorithms. The first come first serve or FCFS. The second is shortest seek time first. Then next is scan, C-scan, look and see look algorithm. Let us look at the detail of this algorithm. Then first is first come first serve. As the name indicates, in this algorithm we service the requests in the order in which they come. Then in this case, no reordering of the work queue. The order in which the request came, the same will be serviced. No starvation. Every request is serviced. That is, no starvation for the request. No process is suffering from starvation. It will be getting serviced in the order it comes. Then for the illustration, we consider a queue of request. That is, this is given, these are the cylinder numbers, that is 95, 180, 34, 119, 11, 123, 62 and 64. This is the order of requests in the queue. And initially we suppose the read-write head is pointing at the cylinder 50, and in this case we assume that there are the cylinders, 200 cylinders are there, that is 0 to 199. And in the case of first come first serve, we diagrammatically represent the scheduling. Actually, this is the top view of a particular platter where the movement of the disk is shown. Then initially it is given that the head is pointing to the cylinder number 50, and after that this is the queue which is to be serviced. In FCFS we know that the request will be serviced in the order in which the request is in the queue. As per the queue, the first request is 95. That is, initially the head is pointing to 50. After that, the head will come to the cylinder number 95. After that, it will come to the 180. Then 34, 119, 11, 123, 62 and 64. This will be the order in which the FCFS algorithm will process the request. And what we have to do is that we have to find out the seek time. Actually, when a request comes, there are head numbers will be given, the track number will be given, and the sector number will be given. In order to process, for the easiness, we consider only the track number, movement of the head in a track only. Therefore, we have to find out the seek time. And in order to find out the seek time, what we do is we take the absolute value of the movement. That is, in this case, from 50 it moves to the 95. In this case, we consider 50 minus 95, the absolute value of the difference. In this case, similarly, we can calculate all the movements and see here 50 minus 95, after that 95 minus 180, 180 minus 34, 34 minus 119. Similarly, we take all the absolute values of the head movement and we get 644. That is, in order to process all these requests, the heads has to move this amount of time. This is the seek time in the case of FCFS. And this is about FCFS. And next we move to the shortest seek time first algorithm. The SSTF algorithm select the request with the least seek time from the current head position. In other words, it chooses the pending request which is close to the current head position. If we consider the example, initially the head pointing to the cylinder number 50, then according to the SSTF, it moves to the shortest which is near to the current position. That is, here we have, in the right side we have 62, in the left side we have 34. From that we find out which is less. 50 minus 62 or 50 minus 34. Here we get 50 minus 62 is the shortest distance from the current position. Therefore, the head moves from 50 to 62. After that, we find out which is near to the 62. Similarly, it is 64, then 34 and continues in this way. And finally, we reach the 180. In this case also, you have to find out the seek time. For that, you take the absolute value of the movement and we get 236. See here the difference, the seek time is considerably less when compared with the FCFS because it moves to the cylinder which is near to a particular point. And Like SJF is the shortest job first, which was the CPU scheduling algorithm. Similar to the SJF, this SSTF also select the disk IO request that requires the least movement of the disk arm from the current position regardless of the direction. Then it reduces the total seek time compared to the FCFS. We see this. Then disadvantages, starvation is possible. Then switching direction slow down the things. Then not most optimal. Then next is the third method is scan scheduling. In the scan algorithm, the disk arm starts at one end of the disk and moves toward the other end, servicing request as it reaches each cylinder until it gets to the other end of the disk. On the other end, the direction of the head movement is reversed and servicing continues. The head continuously scans back and forth across the disk. This algorithm is sometimes known as elevator algorithm because the disk arm behaves just like an elevator in a building, first servicing all the requests going up, then reversing the request the other way. And this is the example. In this case, it starts from 50, then it moves in a particular direction, servicing all the requests. This is next it services 34, 11, and it comes to the extreme end of the disk. And what we need here is that in addition to the movement, we need to know the movement of the direction of the movement of the arm. That is, initially suppose it is moving towards 0 unless it is mentioned, otherwise it will be given in the question. That is, the head will be moving from this direction to this. If it is not particularly mentioned, we assume that the head is moving towards 0. So we assume 50, then 34 is serviced, then 11 is serviced, then it reaches to this end. After reaching this particular end, it reverses its arm direction and it services the other request. In this case, the total head movement is, here we know that it moves from 50 to 0. We can write in a single step 50 minus 0. Then from 0 it moves to the 180. So instead of writing 62 minus 0, 62 minus 64, we can write it in a single step as 0 minus 180. Therefore, we get the seek time as 230. What the extra information we need is, we should know the direction of the head movement. It is taken as moving towards 0 unless it is specified. Then the next is circular scan. Circular scan or a C-scan scheduling is a variant of a scan. It is designed to provide more uniform wait time. Like scan, C-scan move the head from one end of the disk to the other, servicing requests along the way. When the head reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. The C-scan scheduling algorithm essentially treats the cylinder as a circular list. It wraps around from the final cylinder to the first one. Here is the example. In this case, it moves from one end to the other end, servicing all the requests. After reaching the extreme end of the disk, it moves immediately to the other end of the disk without servicing any request. In the case of scan, we have seen it moves to the other end, servicing the request. In this case, it moves to the other end without servicing any request, and from the other end, it again starts servicing the request. We can see in this case, the movement of the direction of movement of the arm in servicing the request is same. That is, in this case, it moves from left to right when servicing the request. This is the difference from scan and C-scan. And in both the cases, the head moves to the extreme end of the disk. Here the disk is having 200 cylinders, which is numbered from 0 to 199. And the heads will reach to the 199 and the 0 while moving back and forth. And in this case, the total head movement is 382. And we move to the next algorithm, look and see look. Look is actually the version of a scan and see look is a version of see scan. Both scan and see scan move the disk arm across the full width of the disk. And here we can see the see scan and the scan, the head moves to the extreme end of the disk while processing the request. But in the case of look, what we can see is while processing the request, here the 50, 34 and 11, then there is no request after the 11. Therefore, the head moves to the other direction. It does not going to the extreme end. This is the difference from look and the scan algorithm. Similarly, in this case, we can find out the seek time. Here, 50 minus 11, 11 minus 180. We can get the number of movement as 208. This is the difference. Then the versions of scan and see scan follow the pattern called look and see look algorithm because they look for a request before continuing to move in a particular direction. It moves whether any further request has to be fulfilled before moving to the reverse direction. Otherwise, it reverses the direction without going to the extreme end. That is the difference. And this is the look. Then what will be the difference of look and see look? After servicing, after reaching this end, it comes immediately to the other end, then starts servicing. This will be the see look. And this is the see look. And in this case also you find out the number of movement. This is 322. And whenever you are asked to find out the number of movements or the number of the seek time by giving a particular queue of requests, what you have to do, initially you draw a line marking the number of heads and number of track or cylinders. Then you approximately you make the numbers 56 into the line and draw the movements of the disk. Then here is the comparison of the different algorithm, and in the FCFS the seek time the number of movement was 644, then SSTF it relatively goes down 236, scan it was 230, C scan 382, look 208, C look 322. And in the case of C look and C scan, it takes a full width of the disk, that is it becomes a comparatively high number than compared to the scan and look. And this is all about scheduling algorithm, and in this class we have seen what is a disk and what is the need of disk scheduling and the various disk scheduling algorithms. Thank you.